Alright, algebra, we are in Unit 6, Lesson 12, graphing the standard form. This is a two-part lesson, so just be aware as you move on to Lesson 13, it's going to really continue. And remember, standard form is ax squared plus bx plus c, where a, b, and c are coefficients, and c is actually a constant, which is also the y-intercept. Okay? That's a quadratic standard form. The linear standard form is ax plus b, where a is the slope. We often use mx plus b, and b is the y-intercept and a constant. Okay, all right, let's dive right in. Graphs a, b, and c represent three linear equations. Y equals 2x plus 4, y equals 3 minus x, and y equals 3x minus 2. I don't like that one, so we're flipping it around. That's a 3. Which graph corresponds to which equation? Explain your reasoning. Well, let's look at graph A. Well, let's actually look at this equation. It has a y-intercept of 4 and a positive slope. So I'm thinking that is graph B, because it's a y-intercept of 4 and a slope of 2, which is positive. So let's look at this one right here. I have a y-intercept of 3 and a slope that's negative. So I think that one is, so graph A, because my y-intercept is 3 and my slope is negative 1, which means this last one should be C. I have a y-intercept that's negative, and that's the only one that gives me a negative y-intercept, and a slope that is positive and also a greater slope, so it's going to be steeper. All right, quadratic graphs galore. Using graphing technology, graph y equals x squared, and then experiment with each of the following changes to the function. Record your observations, including sketches if helpful. So I'm going to get Desmos out and graph this equation. All right, there we go. So first, we are going to add different constant terms to x squared. So here we have the first thought, okay, number 1. Adding different constants to terms x squared, for example, x squared plus 5, x squared plus 10, x squared minus 3. What happens? Okay, that's what we have right here. The red one is the original x squared plus 1. And I am sitting on the, let's say the vertex is on the point 0, 0, because the constant is 0. Now if I do a plus 5 to it, I move my vertex up 5. If I do a plus 10, my vertex moves up to a y-intercept of 10. My constant is 10, my y-intercept is 10. It's connected. Here I'm a minus 3, so I go down to negative 3. Right? That's not a mistake. So when we have x squared and then plus a constant, it just moves your parabola up and down the y-axis on purpose, because the constant is our y-intercept. All right, so take a few notes on that, push pause if you need to, and I'm going to go and sketch number 2. All right, okay, let's look at the next set. So we are on number 2, multiplying x squared by different positive coefficients greater than 1. So here I graphed x squared, and then 3x squared, and 7.5x squared. Now 3x squared is in green, and right there. Okay, notice it got skinnier than our parent function. Okay, this is called our parent function, x squared. It got skinnier. So when we put an a term out front that is greater than 1, our parabola gets skinnier. And if we look, let's do blue. When our A term is bigger, we get even skinnier. So the larger the A term, the skinnier we get. This is actually called a vertical stretch. Vertical stretch. Okay, we're stretching up and down vertically. Okay, the larger our A term is, the more we stretch, the tighter it gets along the y-axis, the skinnier it gets. Okay, let's try number 3, multiplying x squared by different negative coefficients. So let's try a few negatives. So I've drawn another graph. We're on number 3. So here I'm multiplying x squared by different negative coefficients. So a negative x squared and a negative 4x squared. Now what we get here is we go from a happy parabola when the A term is positive, we're happy. When the A term is negative, we're sad. All right, the parabola opens up, the parabola opens down. So when we have just, if we're here in green, negative x squared, it's the exact same parabola as the parent red one, except it reflects over the x-axis. It becomes happy to sad, right? Here, I've put a negative 4. We said when our A term is larger, I think on the last slide I said greater than 1, but when the A term is larger, we're just going to say greater than 1. It gets skinnier. It's a vertical stretch. And then that negative turn, or the negative flips it over the x-axis. It's a reflection. So it's still a vertical stretch. It's just a vertical stretch and an unhappy parabola. So it flips it over the x-axis and makes it skinnier when the A term is a bigger number. And the bigger the A term, the skinnier it gets. And then the positive and the negative flips it over the x-axis. All right? So we're going to try some fractions in this last example. Okay, I hope you're taking notes. All right, here's our last one. We're on number 4, multiplying x squared by different coefficients. Our original x squared is still in red. And the first thing we did in green was multiply it by a number between negative 1 and 1. So we are in fractions. And what's strange is when my A term is a fraction, my parabola gets wider. It's actually a horizontal stretch. Okay, it stretches it this way when it's a fraction. So this green one gets wider when my A term is a fraction. Now this is a positive fraction in green, so we're still a happy parabola versus this next one, it's a smaller fraction. So the green fraction is 1/2, the blue fraction is 1/4, so we've gotten even wider, but we're unhappy because it's negative. So the larger the fraction, the wider we're open. And then I still have when it's positive, it's happy. When it's negative, it's sad. Okay, that was a long video for slide 2, sorry. Long video. Let's move on to the next slide. So this part 3, what do these tables reveal, optional? I'm going to put an exercise in Desmos, a Desmos exercise for you guys to complete. I'm going to put it into your Google Classroom. It's really a good exercise, and if you do this, I'm going to give you a +20 homework assignment. That's double a normal homework assignment, all right? So 20 points extra credit in your homework if you work through this. Okay, in fact, there's another Desmos activity that I really, really love that I will do another +20 if you email me and ask for it. Okay? So you just have to email me and ask me for the extra one, and I will give it to you. All right? What's funny about those types of assignments, those if you email me assignments, is I know if you're paying attention to the lesson, right? So that is your, that's really it. All right, for slide 3. Okay, one more slide. So here we're doing extra credit. Now let's look at this next thing. Nope. This one, a card sort. So here I'm going to have a Google Doc for your card sort in Classroom. It's not extra credit, it's required, and it's 10 points, okay? So a card sort, a Google Doc in Classroom for this last one. And this is the rest of the card sort. All right, so that's the last slide. Good job, okay? Topic 1 was really long. Topic 2 is extra credit Desmos. Topic 3 is a card sort. Nice job today.